Hello and welcome back. We are in our third week of e-learning. I'm sure that all of you are fully aware of that. We are in a third week, so we just have just a few more weeks to go, and it will be the end of the school year. In the meantime, let's get to work and get to learning all the things that we need to learn. So, just a quick reminder, last week we did a small lesson about molarity. We learned about what molarity is, the fact that it is a concentration. We learned about it using moles and liters. Molarity is actually equal to moles of solute over liters of solution. Now, we had that is the simplified, easy, that's the first lesson we're going to get right out of the gate. That is the lesson that you learn. But, as always, it's not how it's going to stay. Luckily for us, this next step is not too bad, to the point where we're actually going to be able to learn our next step and the step further than that within our expected time frame. So, without further ado, let's get to work. So, many of you might have guessed this by now. We were doing molarity with just moles given to us. That's not always going to happen. So, we're going to be working with molarity problems that will be in grams. So most molarity problems that you're ever going to be given, halves, whatever, will be given a mass in grams that you will then work on converting that to moles. So, how do we go from grams to moles? I know it's been a while since we've done a topic like this, but I'm really hoping everyone remembers it. It's molar mass. So, we're going to have moles, we're going to be given grams, and we're going to have to convert to moles. So, some of these are going to be pretty simple, some of them are going to be a little bit complicated. Regardless of which they are, easy or complicated, we're going to have to use the molar mass, which means we're going to need a periodic table. Luckily for us, I am a whiz with a computer, and I know of a bunch of simple websites. The easiest one is the one I'm about to show you here in a second. So, you're going to need a molar mass, convert the grams to moles, as we have for the whole year, so there should not be anything new. And then all you're going to do is take that mole value that you found and plug it right where you would if you were given it in the problem. It's not that bad, so let's take a look at it. So, first thing I'm going to show you this website right here. It's called ptable.com. It is probably one of the most interactive periodic tables I've ever found. It's the one that I used throughout college whenever I could not find one. It is completely updated, has every single element that has been discovered and named. If you want to learn more about something, aka you can't see it, you can just move your mouse over the element of your choice and it will tell you. Everything that it tells you normally upon closer inspection is just right there for you to see. Makes it a little bit bigger. If you really want to, you can click on an element and it will give you the entire Wikipedia page about that element. It's a really great source. It's what I suggest you to use when you're doing these problems. Now, if you have another periodic table, if you have the one that I gave you, that's perfectly fine. You do not need to use this. This is just in case you don't have those or you need an online web resource. This is a great resource. So, for our problem, let's take a look at what we have. I know this is a little small, but you should be able to see it just fine. How many grams of copper 2 fluoride? So we have copper 2 fluoride. So, if you remember way back when we were naming things, what would we have copper, which is Cu, and that has a +2 charge, and fluoride, which is just F. Now, who remembers what the charge on fluoride is? It should be a -1. So, if you remember, the 2 of copper 2 tells us the charge of the copper. Since it's a metal, it's going to have a +2 charge. Fluorine is going to have a -1. So, if you remember, we do our butterfly effect and get Cu1, we can ignore the 1 from now on, F2. and that's how we're going to be able to find our molar mass. So, first thing we need to look at, what do we have? We are looking for how many grams. So we're going to look for a mass in this. Are needed to make 6.7 liters. So our liters is 6.7 of a 1.2 molar solution. So 1.2 molar solution. So if we look at our equation, M is equal to moles over liters. You notice we don't have a mass. We don't have grams. We have moles and we have liters. We also have molarity. That's not mass. So we need to find the moles first and then convert that mole value into mass. So let's go ahead and get to work on that. So we need to get moles by itself. How are we going to do that? Well, we see that's divided by liters. What's the opposite of division? Multiplication. So if it's multiplication is the opposite of division, that's how we're going to get L to hop the fence here. So L hops the fence, leaving us with moles is equal to liters times molarity. So we have liters, we have molarity, so let's just plug them in. So moles is equal to liters, which is 6.7. If you can read my handwriting, if you thought my handwriting was hard to read before, well, you should have learned. 6.7 liters, and molarity is 1.2. So we have 6.7, we have 1.2. We got to take a calculator. 1.2 times 6.7 gives us 8.04. 8.04 moles of CuF2. So I'm going to rewrite that really quickly because that is just going to drive me insane. 8.04 moles CuF2. Very good. So we have 8.04 moles. We can find that in grams. That's not what we're looking for. We're looking for grams, not looking for moles. So we need to make sure that we set up our next equation. So how do we convert from moles to grams? We put what we know over 1. So we know 8.04 moles of CuF2. Put that over 1. We have moles of CuF2, and we have grams of CuF2. We know that's going to be 1 mole for however many grams. So if we want to know find the molar mass of CuF2, all we got to do, Cu is 63.546. We're going to go ahead and round that to 63.55. Add 18.998, which is going to round up to 19. 19 times 2 is 38. So 38 plus our mass for copper, which is 63.55, gives us 101.55. So then cross out units, multiply the top, divide by bottom, 101.5 or 8.04 times the other, which gives you a mass of 816.46 grams of CuF2. Now, I know many of you are wondering, what about sig figs? Well, you're right. Sig figs, we can only have 2. So in total, we're going to have 820 grams of CuF2. So that is the basics of how we do these problems. They're not that difficult. All you gotta do is take the knowledge that we have had before and just use it the same way that we always have. So, not that bad. I know it's not that bad. It's just a little bit of extra work. I'm going to open up a new one of these. Don't save. So, let's do another problem real quick. So we have, what is the molarity of a solution with a volume of 2.5 liters containing 660 grams of calcium phosphate? So, let's take a moment. Calcium phosphate, does anyone know what that is? Well, if you have your periodic table, you'll know that phosphate is PO4 and calcium is on the periodic table. However, if you don't, my suggestion to you would be to look it up. So, calcium phosphate, long family member, gives you the whole thing. Ca3PO4 2. Okay, that's calcium phosphate. It gives us what we need. So, if you look, you can actually find calcium phosphate's molar mass, 310.18. That's the tricalcium phosphate, which is the same thing as what we have. So I'm just going to go ahead and use that molar mass, 310.18 grams per mole. Now, I'm going to point out to you that you should always make sure that you are capable of finding a molar mass on your own, because the internet's not always going to be your friend. But if it gives it to you, go ahead. It's going to be fine. You've already proven to me that you know how to find a molar mass. I care about you being able to use it. So, with that interest, let's see how many grams of calcium phosphate we have. We're told that we have 660 grams of calcium phosphate, Ca3PO4 So, same thing that we just did. The only difference is that since grams are on top, we have to put them on bottom. So, 310 grams, 0.18 per 1 mole of it. So, grams will cancel out. We'll take 660 divided by 310.18 and find that we only have 2.13 moles of Ca3PO4 2. Now, all we got to do is look at our equation. Molarity is equal to moles over liters. Oh, I have moles right here. I'm going to draw that right here. And liters is found in our thing. We're told that we have a liters of 2.5. So, 2.13 moles divided by 2.5 is equal to 0.85 11111118, etc. molar solution. Now, you may notice I have a little bit different answer than you. That's because I didn't round 213 in my calculator. I left the answer and just plugged it into my equation. I wrote 2.13 because I'm lazy and I didn't want to write all of that, but I actually kept it in my calculator. So our answer for this is 0.85 molar solution of Ca3PO4 2. Got cut off there a little bit. So there's another problem. I'm going to leave that in there for you in the notes. I will release these this week, I promise. And we'll get to the next a little